Hi, this is Carly McAvoy doing lesson 12 for the ABE 064 class, and this is the final lesson of the 12 lessons that prepares you to go on to take the placement test to place into Math 90. Remember, if you take the placement test and you don't get the score that you need to go on, then you can go back and practice these videos. You can watch them over and over. You could try it again. Maybe there's one part, maybe just division that you need help on, or maybe just word problems. You can go back and practice those again and again until you get those right. It doesn't mean because you don't pass the placement test that you're done. It means you need to work a little harder. Go back and do it again. Not that you haven't worked hard already, but you need to keep putting the time in. Anybody can get there. If you're willing to put the time in, you can get to the top of that mountain. You may have to go around and around and around, and somebody else is going straight up, but you can get there too. So don't give up. But we're going to talk about, first of all, we finished our last lesson, lesson 11, talking about decimals and fractions and some of the benchmark fractions, but also talking about, is a fraction less than a half or greater than a half or near a half? And so the first thing I'm going to have you do on the new worksheet, on number 12 practice worksheet, is to order fractions from greatest to smallest. So let's say I have the fraction 17/19, and I have the fraction 4/8, and I have 1/7, and I have 7/15. And I want you to put those in order from the smallest to the greatest. What you want to do is think about this. There's 0 over here, there's 1/2 in the middle, and there's 1 to the right. When we're talking about fractions, we're talking about which does this fit in? So let's take the first one, 17/19. 17/19, well, 19 is the denominator and 17 is the numerator, and so we have 19 parts. To equal 1, we would need to have 19 19ths. That would be 1. And to have 0, we would have 0 19ths. And a little tricky because it's an odd number, but what would half of 19 be? Well, if you divided it by half, you'd find it to be 9.5. So if you had 9.5 out of 19, that would be half a half. So 17/19 obviously is way over here on this end of the spectrum. So if I look at this, I know it's way not close to that. It's closer over here to 19/19. So I'm going to just put 17/19 over here. I'm not saying it's the greatest right now, but we're getting pretty close to 1. The next one is 4/8. To get 0, you'd have to have 0/8. To get 1, you'd have 8/8. What is half of 8? It's 4. So 4/8 is exactly 1/2. So 4/8 goes right there. So now I can see that 17/19 is bigger than 4/8, just because if I put them in order in that way, that's what they look like. 1/7, well, 7, if I had 0 over 7, that would be 0. And if I had 7 over 7, that would be 1. What's half of 7? Well, if you divide 7 by 2, you get 3.5. So that would be 3.5 of 7 would be exactly a half. So 1/7, well, that's way less. In fact, 1/7 could be over here, in this range. So far I've got 1/7 to the left, 4/8 in the middle, and 7/19 to the right. But now I have 7/15, and I need to put that in there. And 7/15 looks like this. If I had 0 out of 15, I'd have 0. If I had 15 out of 15, I'd have 1. And what's half of 15? Take 15 and divide by 2, and you get 7.5. So 7.5 out of 15 would be half. And what I have is 7, so it's pretty close to a half, but not quite. So it's actually a little bit less than a half, so it would be 7/15. And by doing it that way, I didn't do any real calculations except finding that halfway. But by doing that, I could see that I have 1/7, then 7/15, then 4/8, and then 17/19. So from least to greatest, I have 1/7, 7/15, 4/8, and 17/19. And that's how you can order fractions, by just deciding whether they're closer to 0, closer to 1, closer to 1/2, and putting them in line there. That's number 1 on your mixed review. Even though that's not exactly a review because we didn't do it before, but we did talk about deciding whether something was closer to 0 or 1. The next thing on your lesson 12 is ordering things that are decimal numbers. So let's say I have 7 and 1200ths, 7 and 100th, 7 and 2700ths, 7 and 1500ths, and I want you to put those in order from least to greatest. Well, they all have a 7, so that doesn't help. 7 and something, that puts it pretty close. So the first thing you're going to do is look at the tens place. Remember, tens is the first digit to the right when you look at decimals. In fact, just a quick review on how to read this. This would be 7, the first one, 7 and 12, and then it's 2 decimal places, so 7 and 12 hundredths. Because all these are hundredths because they end in that hundredths place. Look to the tens place. And the smallest number in the tens place is that 0. So that's our smallest number, or I should say our least number. 7 and 100, even though it's 2 decimal places, that's why it ends in 100, even though there's only just that 1 in there. That means that this one is taken care of. Now I'm looking at the next one is 1, and there's 2 of them with a 1 in the tens place, so that doesn't tell me anything. So then I look one past that and look at the hundredths place. When I look at the hundredths place, I can see that 2 is less than 5. So that means that the next number in order would be 7 and 12 hundredths. Then I would have the 7 and 15 hundredths, because that was the next one that had a 1 in the tens. And that means that 7 and 27 hundredths is the greatest number on our list. So there's ordering numbers with decimals. But let me show you one more thing, because I think this is important to look at too. Let's say I have 7.1, 7.09, 7.401. Sometimes they all have different amount of decimal places, 1, 2, or 3 decimal places. And so you still can do it the same way. Look to the tens, look to the ones, look to the hundreds, look to the thousands. If these all have 7s, then I know I can look to see what's the smallest I have in the tens place. Even though it has a lot of digits, doesn't mean that it's the greatest or the smallest or whatever. The smallest number, the least number that I have then is the 0 there. So 7 and 9 hundredths is the smallest number. The next greatest number I have is 1, or the next smallest number is 1. Next greatest, I said that right the first time, is so 7 and 1/10 is the next number on my list. And finally, the 4 makes that the largest, 4 in the tenths, so that would be like that. So notice that this has 2 decimal places, and this one only has 1, but the 2 decimal places is still smaller. It depends on what number is in the tenths place that makes the difference, not any other way. Okay, let me see if you can do this on your own. Let's do 4 plus 4 is 8. 5 times 2 is 10. 21 divided by 7 is 3. 6 minus 2 is 4. What I would like you to be able to do is tell me, what do you call the answer to an addition problem, a multiplication problem, a division problem, and a subtraction problem? We've been doing that all along, practicing. Addition, we start off with the very second lesson, and we've been practicing that all the way through. So do you know what you call the answer to an addition problem? That's a sum. To a multiplication problem, it's a product. Subtraction problem, I just asked my students that. They're in Math 99, so that's, they went through what you did, and then 90, and 94, and 98, and 99. They're 4 classes ahead, and still some people weren't sure of these answers. So if you have that down, you're ahead of them on that. And then the answer to a division problem is quotient. So you should know those 4 terms by now, vocabulary terms. All right, so what I see on here is arranging fractions from least to greatest, arranging decimals from least to greatest, matching these terms, and then I give you 4 problems to do where I don't tell you what the operation is. I just say perform the operation, and I give you product, difference, quotient, and sum. And so you need to be doing those things. Number 7, find the product of 304 and 33. What is that? What operation? That's multiplication. Multiplication, we're going to do, doesn't matter that if we line things up or not. You're going to do that multiplication problem. By now, that's a skill that you should have down before you went on for multiplication. So I'm not going to work that out, but I do want to show you that. That would be a multiplication problem. What about the next one? Find the difference of 1009 and 24. What operation am I asking you to do? Subtraction. And remember that when we say the word difference, whatever we say first, that goes as your minuend on the top. And what we say second is your subtrahend on the bottom. 1009 and 24. That's a subtraction problem. So that's really more about the vocabulary than about doing it. I want you to do it too. But I wanted you to practice that on your own. But that's how you would set that problem up. The quotient of 6,143 and 17. So, what operation? Quotient is division. And whatever you say first is your dividend. 6,143 divided by 17. That's how you're going to set that problem up. Okay. Do the division, check it by multiplying. And finally, the sum of 5,249 and 126. What does the sum tell you to do? It tells you to add 5,249, 126. 5,249 and 126. I may not have remembered that correctly. 5,249 and 126, right. Those are the 4 operations that you would perform for that. You want to do those? I mean, I think you can do them on your own, but I'll do them really quick. 3 times 4 is 12. I'm going to carry that 1, but I'm going to end up bringing it down. 3 times 3 is 9. You're multiplying by 3, but that's actually a 30, so you put the 0 in. Same thing happens again. 3 times 4 is 12, and you bring that down. 3 times 3 is 9. 10,032 for the multiplication problem. For this one, you subtract 9 minus 5 and get 9 minus 4 and get 5. You have to borrow, and that takes that away completely. This becomes 10 and this becomes 9. 10 minus 2 is 8, and 9 minus nothing is 985. How do you check those? Check by adding. Add this up: 9, 10, 10, carry a 1, 1009. So you know that that's your answer because you added your subtrahend and your difference and you got your minuend. Remember that? Okay, 17, dividing by 17, this is one where we didn't really think you had all those memorized. What I suggested was that you write down your 17s. I'm not going to write 1 times 17, but 2 times 17, just 17 plus 17, that's 34. 3 times 17, add 17 again, you get 51. You can do the addition off to the side, you don't have to do it in your head. Whoops, I got the wrong thing going on here. What I want to do is do 4 times 17. That's going to be 68. 5 times 17, that's going to be 85. 6 times 17, that's going to be 102. 7 times 17, that's going to be 119. 8 times 17 is 136. And 9 times 17 is going to be 153. Notice my pattern when I multiply by an odd number like 17, it's even, odd, even, odd, even, odd, even, odd, my answers are. So that's just an interesting little fact. Okay, so how many times does 17 go into 61? If you did this chart over here, then you could see 4 is too many, so 3 is our answer. 3 times 7 is 51. The only reason I would do the numbers off to the side like this is that I don't have to do the multiplication in the problem. But sometimes you do a lot more work, a lot more multiplications than you really need, but it does take some guesswork out of it. When I subtract, I get 10. I'm going to bring down my next number, which is 4. How many times does 17 go into 104? Well, right here, it goes 6 goes into 102, so that's what I want to put in there. 6 times 17 is 102. Subtracting, I get 2. And then I'm going to bring down the next number, 3. How many times does 17 go into 23? 1 time. Subtract, and I get 6. And so my answer in fraction form is this, 361 and 6/17. How do you check that? You should have been checking your division problems all along because it's so helpful to feel good about a problem and walk off and go, I know I got that right because it worked out when I checked it. And that is to take your quotient, 361, and multiply by your divisor, which is 17. And you can do the multiplication off to the side like I'm doing. Add your numbers. I get 6,137, and then what? Add your remainder, plus 6. I really didn't leave enough space here. 13, carry the 1, that gives me 4. 6,143. That is my dividend that I started off with, that I know that I did this correct, so I feel good about it. 361 and 6/17, my final answer. Adding up over here, 9 and 6 is 15. 4 plus 2 is 6 and 1 is 7. And when I add, I get 5,375. So you can always do a problem twice to make sure you get the same answer both times. So sometimes you make a mistake the first time, the second time you can check it that way. All right, so that's those problems, mostly just a vocabulary lesson more than anything else. And then we get into our order of operation problems. Remember, we did a whole lesson on order of operations, and I just want to make sure that you remember that. 25 times 4 divided by 2 times 5. That's the problem on your paper, so I'm going to do a little different problem. Okay, same type of thing, but this way you can practice your problem and I can practice the other problem. And remember, the rules are please, excuse, my dear, and Sally. And also remember that multiplication does not always happen first. It happens left to right. Addition, subtraction does not always happen first. It happens left to right. So I'm going to do the multiplication because that came first. 30 times 2 is 60. This says multiply. So does this. It's a little different because on the right side I put 2 sets of parentheses, on the left 1, but they both mean multiply. 30 times 2 is 60. Then the next thing comes along is division. I don't want to jump over and multiply next. You don't do what's inside the parentheses unless there's something to do inside the parentheses. There's nothing to do inside these. They're just a 3 and a 2 sitting inside there. So the parentheses in our case just mean multiply. So 60 divided by 3 is 20. And 20 times 2 is 40. So the answer to that one is 40, and you're going to follow the same procedure for the one on the left that was actually on your paper. All right. 4 plus 3, 2 cubed minus 2 plus 3. I'll never remember all that, will I? I don't know. 4 plus 3, 2 cubed minus 2 plus 3. Something like that. I'm going to change the problem so that you have an example to look at. Similar problem, different numbers. Always do what's inside the parentheses first. And what's inside the parentheses, we have exponent and we have a subtraction and an addition. We're going to do the exponent first. Remember, 3 to the third power is not 3 times 3. It's 3 times 3 times 3. There's 3 3s. 3 times 3 is 9, and 9 times 3 is 27. So 3 to the third power equals 27. So I have 5 plus 4, 27 minus 6 plus 1. I'm going to continue left to right with addition and subtraction. I don't do addition before subtraction. I work them left to right. So the next stage is 27 minus 6. I should do that. 27 minus 6 is 21 plus 1. Next, I'm going to continue inside the parentheses. Remember, parentheses are just one of many grouping symbols, and you always work inside the grouping symbols. You might have brackets or braces, but they're still the same meaning. What I have left now is addition and multiplication, and I'm going to do the multiplication before I do the addition. So I have 5 plus 88. And when I add those together, I get 93. So there's the process, same process. You're going to do it with different numbers over there, but make sure you're following that procedure. A common mistake is for people to do 5 plus 4 and then times that times 22. Remember, you don't add before you multiply. You always multiply and then add. All right, the next one's the square root of 64 plus 10 minus 5 squared. So, changing it up, I'm going to do the square root of 81 plus 7 minus 1 squared. Okay, The square root of 81, remember all that is asking you the question, what number times itself equals the radicand? The radicand is that number underneath there, remember? We have radicand, and we have the radical, right? So we're asking what number times itself equals the radicand, and that number would be 9. But inside the parentheses, I'm going to solve that step. 7 minus 1 is 6. I jumped the gun a little bit on the radical. It doesn't really matter, but if you were following the true steps, you would do inside the parentheses first, and then you would take care of the square roots and the exponent. So I'm going to go back and fix that, which I did. 7 minus 1 is 6, and now I'm going to take care of the square roots and the exponents going left to right. 9 times 9 is 81. That's what that question is. I no longer have a square root symbol on it because I did that operation. And now 6 to the second power is 6 times 6, which is 36. 6 to the second power is not 6 times 2, it's 6 times itself. You should be able to be given this and write that in shorthand form. 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be 2 to the 9th power. Or be given this and write it out in longhand. 3 times 3 times 3 times 3. So you should be able to go back and forth between those. 6 times 6 is 36, and 36 plus 9 is 45. So there's that one solved for you. You're going to do more of solving using the order of operations, or simplifying using the order of operations when you get into Math 90. So don't get too upset about it now. It's not part of your transition test, really. You have to know other things to get there. So this one's got a fraction bar, and it's got 18 plus 5 minus 2 plus 9. And on the bottom, I don't think there's any parentheses. On the bottom we have 1 to the third minus 1. So let me give you one similar. Similar, but different. When you have addition and subtraction, sometimes people tend to want to jump in and do both the addition parts and then subtract. And remember that as addition and subtraction go left to right, whichever comes first. So in this problem, I'm going to go ahead and say 25 plus 3 is 28. 1 to the 5th power is 1 times 1 times 1 times 1 times 1. 1 times itself is always 1 no matter what. Remember, when you're working with a fraction, you do the top part, and then you do the bottom part separately, and then you divide afterwards. So moving on, 28 minus 3 is 25, and 1 minus 1 is 0. Red flag. When you get a 0 in a fraction, you should be thinking, whoa, 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 what's happening here? One more step is 25 plus 4 is 29. But when you divide by 0, you either get 0 or undefined. Which one is it? When you divide by 0, your answer is undefined. You cannot divide by 0. Under is undefined. You can't do it, so that's going to be 0. If you work that problem and you got 0 on the top, so if it came down to something like this, that's different. 0 is the divisor here. Over here, 0 over 7, 0 is the dividend. If it's the dividend, you get the answer of 0. Remember, 0 and undefined are two different numbers, totally different, two different things. One of them is a number, one of them is just saying undefined. There is no number for that. They're two different answers is what I should have said. Okay. And then we have a couple of word problems. And the word problems aren't the hardest in the world, but we just want to make sure that you know how to do that. Julio drove from Kansas City, Missouri to Denver, Colorado in 12 hours. If we average 62 miles an hour for the trip, how many miles did he drive? So we already are telling you what his average is. We're not asking you to find his average, which would indicate division. But we're just saying that he did average that. I almost want to make that bold. So he did 12 hours at 62 miles an hour. So really this is just a multiplication problem. You're going to multiply 62 times 12, and that's going to tell you how many miles he drove. He did 62 miles repeatedly, hour after hour after hour after hour. When you have something repeated over and over and over like that, that's a multiplication. Did 62 miles, 12 hours, and so 62 times 12 is going to get you your answer. I'll let you do that one on your own. I will show you to write it down just in case you're not a great learner by hearing. Some people have to see it. This is what I'm talking about. He did 62 miles per hour for 12 hours in a row, and that's the problem that I want you to solve then, 62 times 12. Some people need to see the visual on that. Okay, and the last one, 5 children agreed to share the profit from the estate sale equally. If they made $14,675, how much did each person get? What kind of a problem is this? If you said division, how do you know? Well, what you should know is that sharing something, when you share something equally, you're dividing it up. Each of these people are getting their share, which is a little divided part. So it's division. There were 5 children, and it's $14,675. And we're dividing it up 5 ways. This is going to come out exactly equal because 5 goes into every number that ends in 5 or 0. If you count by 5s, 5, 10, 15, 20, 25, 30, 35, 40. You can see that there's a pattern. They all end in either 5 or 0. So I know 5 goes into this evenly, and so you're going to do the division there and see what you get. This is the practice worksheet, so you want to practice it, bring it in, have your teacher grade it, and see how you did on it. I'd like you to try that just so you can practice that division. Division is one of the things that's hard for people as they go into basic math, so it's good to practice division and not have somebody always doing it for you, because it always looks easier when somebody else is doing it. Okay. So I think we have everything on the practice sheet. Then you have to arrange fractions, arrange decimals, know the terminology, and know the terminology again to practice those if you're asked to find sum, difference, product, or quotient. And then practice with the order of operations. That's a tough thing, and if you're not great at it, don't get too worried about it. Again, that's not going to be part of your transition test. But ordering decimals is, and knowing these vocabulary, that is. So make sure that you know that. And then being able to add, subtract, multiply, and divide, that's all part of your transition test. So that's what you want to make sure. And also on the transition test, they have a few word problems. So I think there's maybe 4 or 5. So you want to make sure that you can do word problems. You've had a bunch of practice with word problems, some really hard, some not as hard throughout this time with the 064. So I think if you can do those, you'll be ready for the test. All right, it's been great working with you, and I hope you have a fantastic time as you move on to Math 90. Thanks. I'm saying to stop the recording, but it's not showing that it is stop the recording, so let's see if it's in here stopping it.